All right, this is 11.7 part 2. We're going to do some practice with volume and surface area. So here we're going to find the volume of the cones. So from our previous note, we have the volume of a cone is 1/3 pi r squared times the height. So this one, you need R and H. We have 7 and 13 is the height. So the volume here is 1/3 pi times 7 squared times 13. Put that all in your calculator. We get 667.06. What are the units? Well, it's volume, so it's cubic units, and we're doing inches. All right. Now here, again, we need R and we need H. We have the radius is 5, but what's the height? The height would be here, so we're going to have to use the Pythagorean theorem. So 5 squared plus that height squared would give us 8 squared. (25) plus h squared equals 64. So h squared equals, subtract 25 from both sides, you get 39, which means h is the square root of 39. We could just leave it like that. We don't have to write a decimal or anything like that. The less decimals we have to write out, the better. So my volume is 1/3 pi times r squared, so 5 squared times the square root of 39. Put that all in your calculator in one big shot. Make sure you're putting parentheses around what needs to be, otherwise you should do it in smaller pieces. You should get 153.95, and that's going to be meters cubed. Don't take my word for it. Make sure you're putting this in your calculator and you can get the same thing. All right? So you know that even if you understand the concept, you want to make sure you're putting it in the calculator correctly. And lastly, we have a radius of 2.2 and a height of 4.5. So we have 1/3 pi times 2.2 squared times 4.5, and that's going to give us 22.81 centimeters cubed. Again, so pause this video so you can take the time and put that in your calculator. Next, I want to find the volume and the surface area of the composite solids. So let's find the volume first. That's probably what we're most familiar with. So here, the composite solid, it's a cylinder with a cone on top. So I need to find the volume of the cylinder plus the volume of the cone. So what is the cylinder? Well, from a previous section, the volume of the cylinder would be pi r squared, so the area of the base times the height, plus the volume of a cone we have just learned is 1/3 pi r squared times the height. The special thing is that those are different heights. We want to make sure. So this is the height of the cylinder. This is the height of the cone. So it's not the same. So let's plug those in. We have pi. What is the radius? It's the same for both. So the radius is 6 times the height, and this is of the cylinder, so the height of the cylinder is 5, plus 1/3 pi r squared times the height of the cone, which now is 4. You put that whole thing in your calculator, you're going to get 716.29 meters cubed because we are doing volume. Same thing for here. We want to do the volume of the cylinder plus the volume of the cone. So pi r squared, the height of the cylinder, plus 1/3 pi r squared times the height of the cone. So that should be 3 for both of them, the radius at least. So pi 3 squared times the height of the cylinder is 10, plus 1/3 pi 3 squared times the height of the cone, which is 5. Put it all together, you're going to get 329.86 centimeters cubed. All right, now let's work on surface area. Now, the challenge here is it's not just a cone like before, it's a cone with a cylinder bottom. So something to keep in mind is that the surface area of a cylinder is two circles and a rectangle. So the idea is if you were to curl this up, that creates the outside, and then there are 2 circles on the bottom. So how would you find the surface area of a cylinder? Well, this would be pi r squared, and this is a rectangle, so it's length times width. But in this case, the length is the height, and the width, if you can imagine if you curled it around, is going to be the circumference of the circle. So the surface area of a cylinder is pi r squared plus pi r squared plus 2 pi r times the height. That would be the surface area of a cylinder. So the 2 circles plus that rectangle in between. Now this in this case is the cone, the top of the cone, that lateral area, that rectangular piece that's wrapped around, and that bottom circle. So to find the surface area here, it's the lateral piece of the cone plus the side of the cylinder plus the circle base. So that lateral piece, so just the part that's sticking up, if you look at your formula from the front, the surface area is pi r squared plus pi rl. That pi rl is what we're looking for. The side of the cylinder, that's this rectangle here, 2 pi r times the height of the cylinder. And the circle base is pi r squared. So if we look at this, this piece is missing something, and that's L. I have the R, I have the height, I don't have L. So L, if the height is 4 and the radius is 6, what's that lateral space? Well, you'd have to do 4 squared plus 6 squared equals L squared. 4 squared plus 6 squared is 52. So L is the square root of 52. I'm just going to leave it like that because I want to write as few decimals as possible. So I have pi times the radius is 6 times root 52 plus 2 pi r. 2 pi 6 times the height of the cylinder is 5 plus pi 6 squared. That's a really tricky one, but I believe in you. That should give you 437.53 meters squared. So it's meters squared because now it's area. We're doing the surface area on the outside. Now keep in mind, this is the same thing. It's the lateral piece, just like the pointy part, the side of the cylinder, and the base circle. That's the surface area. That's all that would be on the outside. So pi RL plus 2 pi r times the height plus the base is pi r squared. So again, pi RL, what is L? Well, we have 5 squared plus 3 squared equals L squared. 25 plus 9 is 34. All right, so our L is the square root of 34, and you can plug it in directly into the equation. So we have pi times 3 times the square root of 34 plus 2 pi times 3 times the height, which is 10, height of the cylinder, plus pi times r squared, which is 3 squared. Put that all together, 271.73 centimeters squared. So these ones are tricky, but the main idea is just with the cones to make sure we have that volume and surface area formula with us, especially when we are doing the homework. All right, which you can now start.